Have you ever been in a packed stadium or a busy airport and wondered how on earth your phone gets a clear signal? I mean, with thousands of other people using their devices all at once, you'd think it would just be a giant jumbled mess of data. Well, today, we're going to talk about a really clever technique designed to solve that exact problem. It's called Interleaved Division Multiple Access, or IDMA for short. So here's what we're going to cover. First, we'll look at the wireless traffic jam that made something like IDMA necessary in the first place. Then we'll introduce IDMA itself as the solution. We'll get into the nitty-gritty of its clever trick, check out its key benefits, and finally see where this tech shows up in the real world. You know, to really get why IDMA is such a big deal, we first have to rewind a bit and look at the headaches older systems like conventional CDMA were dealing with. It really all boils down to one word: interference. Just think about it like a crowded room where everybody's talking at the same time. It's chaos, right? When lots of people try to use the same wireless channel, their signals can clash and just pile on top of each other. This creates a kind of traffic jam in the airwaves, and it slows everything down for everyone. A really popular technology for a long time was Code Division Multiple Access, or CDMA, but it had some pretty serious limitations. Its performance was held back by two big problems. The first is multiple access interference, which is exactly like that crowded room. You're trying to listen to one person, but everyone else's conversation is getting mixed in. The second is inter-symbol interference, which is where a single signal kind of starts to blur together, almost like words slurring into one another. And trying to unscramble all of that at the other end, man, it was incredibly complicated and used a ton of processing power. So with all these challenges, the stage was pretty much set for a more innovative approach to come along. A way to handle all that data traffic without the collisions and the complexity. And that's where IDMA comes in. It's basically the next evolution of CDMA, but it was specifically designed to tackle those big problems of interference and complexity head-on. That's why people often call it a next-generation technology. It's just a much smarter and more efficient way to handle all our wireless communication. Okay, so this is the crucial part. How does IDMA actually manage to separate everyone's signals so cleanly without the same old problems? Well, the secret, it's right there in the name: interleave. The real magic behind IDMA is a unique component called an interleaver. You can honestly think of it as the beating heart of the whole system. It's the key that lets us tell one person's signal apart from another's, even when they're all talking on the same channel at the same time. Now, this diagram might look a little intimidating, but it's really just the basic blueprint of an IDMA system. On one side, you have the transmitter, which gets the signal ready for its journey, and on the other, the receiver, which decodes it. Let's just focus on the transmitter side first and see how that clever shuffle gets set up. The process starts with some standard stuff like encoding and spreading the data, but step 3, interleaving, that's where the genius comes in. This is what's so cool. Every single user gets their own unique shuffling pattern. It's like a personal signature that scrambles their data in a very specific way that no one else has. A really great way to picture this is with a deck of cards. Imagine your data is a perfectly ordered deck. The interleaver takes that deck and gives it a special shuffle that's unique to you. My shuffle is different from your shuffle, and yours is different from everybody else's. This user-specific scrambling is exactly how IDMA can tell all the signals apart, even when they're all overlapping. So when all those uniquely shuffled signals arrive at the receiver, a special component called an elementary signal estimator, or ESE, goes to work. Think of it like a signal detective. Its main job is to spot any interference and clean up the signal. It's only after that cleanup that the receiver applies your unique de-shuffling pattern, the exact reverse of the shuffle, to perfectly put your original data back together. Okay, so we've got this super clever shuffling technique that acts like a unique signature for every user. But what are the real-world benefits? What's the big payoff for doing things this way? This is where you really see the core advantage. Remember how conventional CDMA struggled with all that interference and needed these complex, power-hungry receivers to sort through the noise? Well, IDMA's approach cuts down on that interference right from the start. And that means the receiver's job is way, way simpler, which makes the entire system so much more efficient. And that simpler, more efficient design leads to a whole laundry list of benefits. Because IDMA is way more efficient with bandwidth, it can support higher data rates. For you, that just means faster downloads. And since the receivers aren't working as hard, they use less power, which is fantastic for the battery life on your devices. On top of all that, it still keeps the classic toughness of CDMA, so you get a strong, reliable connection. It really is the best of both worlds. So this all sounds great in theory, right? But where is this technology actually being used? Let's take a look at some of the practical applications where IDMA's unique strengths really make a difference. IDMA's high efficiency makes it a perfect match for technologies that need to be both super fast and super reliable. For example, it's used in ultra-wideband systems. The tech that lets you transfer massive files between devices just by having them near each other. It was also a key ingredient in the recipe for 4G mobile networks, helping to give us the fast, stable connections we all came to depend on. At the end of the day, IDMA is just a fantastic example of the kind of innovative thinking we need to keep pushing wireless tech forward. It shows that by finding a clever new way to look at an old problem, like using a unique shuffle to separate signals, we can build faster, more efficient, and more reliable networks for our increasingly connected world. It definitely makes you wonder, what's the next clever trick going to be?